Right now, we are conducting a service learning, which is how we as a UTM student can help the community by teaching something new to them. This meeting is organized to follow our service learning for the subject Communication Principle SEEE 3533. To this meeting aims to provide, teach, and lecture our participant on one of the basic communication system topics, which is noise and loss. This lecture will help us provide information on how much the community around Malaysia understand the communication system that we have in this modern era. Next, I will be introducing our panel for today. We have Mr. Omar Muhammad Ahmed Sultan Ahmed. We have Mr. Chua Hua Lee Jonathan. Me, Mr. Haziq Hakirin bin Harun Rashid. And lastly, we have Mr. Ahmad Fauzan bin Abdul Rahman. This lecture is conducted with permission from our lecturer, Mr. Dr. Omar Abdul Aziz. Next, we've been having our first quiz for today's session to see how much you guys know about noise and loss in communication system before entering this lecture. This first quiz will be a reference point for us, and later we will do this quiz again to see does this service learning program can actually help you guys understand more on this topic. I will be giving the link so you guys can answer it for 15 minutes. So next, this is the subtopic that you guys will that we are going to cover on the noise and loss in communication system. All right. First thing first, we will start with an overview of communication system. What is exactly a communication system? Communication system is a process of sending information signal from one point to another, which consists of these three process, which are receiving, transmission, and processing. Basically, you can guys can take an example. You guys are using of your phones. From your phones, you are calling someone. So from when you calling someone, the signal you guys are transferring is your voice, maybe, and you first your voice is called as transmission, and then when so the voice will be converted into some kind of signals that can be transferred into another person that we call as processing, and then after receiving the your voice, it calls as receiving process. And then next we have a component function in basic communication. We have a source, input transducer, transmitter, transmission medium, receiver, output transducer, and destination, which is also called as output. So how we can put all of this into a diagram. So based on the figure, you guys can see how can we use the process and function that I already told you into an application. So for the first term, yeah, that you guys can know to understand more on this topic of communication system is modulation. Modulation is basically a process modifying carrier signal to carry information from one place to another. Basically, you guys are trying to uh, change the carrier signal that you guys have in a signal so that you guys can transfer it into certain places. So from this diagram, you guys can have this ST we call as the input signal, and then the signal that we have, we will transfer into input transducer. So in this input transducer, your signal, for example, you have input signal as a, maybe we can sound wave signal. You transfer this sound wave signal into input transducer. In the input transducer, your sound wave signal will be converted into a signal which is called as modulating signal. Basically, it's a signal before undergoes modulation process. So this modulating signal will transfer into this process which we call as transmitter. In this transmitter, we can do a process which is modulation. So the modulating signal that we have, we will convert it into modulated signal, a signal that already undergoes this process. And then the modulated signal will be passed into transmission medium. So what is this transmission medium? Transmission medium, we have two kind of them, which is wired or also called as guided, and also wireless, which we call as unguided. So wired, some example of wired transmission medium is like fiber optic, uh, and many modes of wire that I think we already learn in physics in secondary school. And then some wireless is free space of to use satellite. So for example, you are using satellite to transfer a signal from one place to another. That is called as transmission medium. And also after that we have receiver. This receiver will be receive the modulated signal from the transmitter, and at the receiver we will do a process called demodulation. It's basically a inverted process of modulation. It make the modulated signal that we have from transmitter back into modulating signal. And then this modulating signal from the receiver will pass into output transducer so that it can convert it into the sound wave signal that we have in this input. So basically we pass sound wave signal and then you will receive also sound wave signal. And then we also have this noise. This is basically the topic that we will cover today. And last, for the overview of for communication system, we have 5 functional processes in communication system, which is modulation. Modulation, I already told you before, which is the process of altering a signal to understand the data better. So basically, we have 3 type of modulation in communication system. We have amplitude modulation, AM, we have frequency modulation, FM, and also we have phase modulation, which is called as PM. Next process is multiplexing, basically combining a multiple signal into one signal over a shared medium. So you guys have two signal. So from these two signal, when it undergoes multiplexing process, it will combine into one signal only. Some type of multiplexing, we have two type of them. We have functional, we have FDM, which is the functional, frequency division multiplexing, and also we have TDM, which is time division multiplexing. And the next process is encoding and decoding, which is a change format of content for storage or transmission. I will give you some kind of analogy. We have video, which is in file type of MP4, and then you want to store in sound only file. Sound only file type is MP3. So how you guys can convert this MP4 into MP3? We use the process of encoding and also decoding. Next process is error detection and correction. Basically, the name of it already explained. It's detecting any problems and correcting those problems to ensure the reliability of the transmitted data. And last process is signal amplification. It's basically a process of increasing the intensity of a signal to strengthen weak signal during transmission and reception. So when you guys are inserting maybe one kind of the signal amplification is amplifier. When you guys uh, put amplifier into a system, it can increase the intensity of the signal so that the signal can travel in the long distance. And lastly is the for communication system is the application of it. We have telecommunication, which is basically you guys are doing right now. We are using smartphones or laptop to communicate with each other. And then we also have broadcasting. We have TV and radio. For your information, at the modulation process, I already told you is frequency modulation, basically FM. That means by FM radio. And then we have data communication, which is internet. We have 4G or 5G, and also one more example is LAN, local area network. And then we also have remote sensing and satellite system. And lastly is healthcare. Next, I will be given the mic to Mr. Fauzan to explain about what is noise and loss. Please.
Thank you so much, Mr. Shakilin. So we've already talked about the overview of the communication system, right? So now we're going to go into the topic that we are going to talk about tonight, which is noise and loss. So basically, we just translate the word noise and loss from the English dictionary. So noise is something like the sounds that the unwanted sounds, like for example, you are taking online class and then your little sister or your little brother in the background is making noise. What is that noise? Noise like the unwanted sounds. And then there's loss. Loss is something like that you are missing or something that is gone, something that is not there anymore. Like so, this definition is quite similar to the one that we use in communication principle. So, in technical terms, noise is any unwanted signal that interrupt the original signal during the process of transmission, receiving, or processing, and then this noise will cause distortion to the signal and will degrade the quality of the signal. And then for loss, however, it is about reduction of effectiveness and basically the strength of the signal will reduce because of loss. Next. So there's a lot of type of noise and loss. So, but basically the general type of noise is there is internal noise and external noise. Internal noise comes from the interference from the device or without the electronic circuit. Like for example, you are using microphone, right? The microphone itself can create noise. And let's say you are listening to a speaker or earbuds. Those electronic devices can also produce noise that will distort the signal that you are hearing. So internal noise can be classified as two types. First, there is the thermal noise, which is caused by, in technical terms, it is caused by random electron movement in the electronic circuit. And then there's also short noise, which is a random arrival of carriers at the output element of the electronic device. It's very technical terms, but that is the definition of it. For external noise, it is a noise that is made from man-made source or natural source, which is basically from the outside of the communication system. Like for example, there's lightning, solar noise, ignition, and crosstalk. Then that's about noise. There's now multiple types of loss. So first is attenuation loss, which is the loss that is comes from the weakening as the signal is traveling to different medium. Like for example, you are talking to your friends, like imagine yourself in a field. You and your friend is like 100 meter across. When you try to talk to them, they cannot hear it. Why? Because the voice that you are transmitting, when it reaches 100 meter, reaches your fan, it will be very low and very small in volume. So that is basically what attenuation not loss is. The signal that you are transmitting will be weakened as it travels to a medium. And then there's also absorption noise where the signal is absorbed by the surrounding. There's reflection and scattering loss where the signal is bouncing around obstacles or other things, and it will reduce the energy inside the signal. And there's also connector loss, which is caused by poor quality cables and component in the communication system. And now we talk about what is noise, what is loss, and what is the type of them. Now, how does this noise and loss affect the communication system that we are using in our everyday life? So first of all, like we said before, the noise will distort the information and making the messages that we send very hard to understand. And then part of the message that we transmit will also be lost because of the noise and loss. And the messages that are received will be incomplete. And because of that, the efficiency of the communication system will be reduced. So basically, efficiency is a ratio of output over input. Basically, if the higher the efficiency is, the greater the system is. So when there's a lot of noise and there's a lot of loss, the efficiency will be reducing. Basically, it's saying that the communication system is very bad. And then yeah, because it is very bad, the communication system will be unreliable, and there will be a need of expensive solutions to reduce this loss and noise. So that's how basically in general how noise and loss will affect our communication system. And next, I'll be passing to Mr. Omar, which will talk about the causes of noise.
Thank you, Mr. Fauzan. First of all, I would like I see some cameras are still off, so it would be better if you guys turn it on so we can express the knowledge that we have with you better. So I would like to talk about the causes of noise in communication system. So as Mr. Fauzan has mentioned earlier, we have two big problems in communication system, which are noise and loss. So these things can mess up the signals, whether you're using Wi-Fi, cables, or even fiber optics. So let's break it down. First, the thermal noise. It happens because of heat. So when electronics get warm, uh, when the electronic devices get warm, it gets hotter. So the electron inside the electrons inside the devices start moving randomly in the device. So this random movement creates a tiny and unwanted signal. It's also like a static on a radio when it's warm. All electronic devices have also this kind of noise, and it gets worse as it gets hotter. Second, we move to the interference. It's another big problem of noise. This is when other devices or signals mess up with your signal. For example, power lines, motors, or even other communication system can create electromagnetic wave that interferes. It's like when your Wi-Fi slows down because your neighbor is using another one. So the other is the atmospheric noise. This is caused by natural events in the atmosphere, like lightning or solar flares or cosmic radiation. These events can create electromagnetic wave that interferes with our signal. So you have also probably heard of cracking sounds on AM radios during like the thunderstorm, because this is because of the atmospheric noise. Next. Next, we also move to the quantum noise. In systems that use light, like fiber optics, we have quantum noise. This happens because of the light is made up of tiny particles called protons, and they don't always behave perfectly. It's like trying to count raindrops in a storm. Like some will always be unpredictable. And this is also a picture of the quantum noise. Next is a shock noise. Electricity is made up of tiny particles called electrons, as they don't always flow smoothly. When electrons jump across gaps, like in diodes or transistors, it creates a small random fluctuations. Like you can imagine it as water dripping from a tap instead of flowing smoothly. This is the example of the shock noise. And lastly, in noise, we have the impulse noise. This is like random loud burst of noise caused by things like lightning strikes, power surges, or turning on a heavy machine. It's like hearing a loud pop on a phone, like during a thunderstorm. This burst can cause errors in digital signals. So as you see in the picture here, this is also an example of the impulse noise. So noise is a big problem in communication system. It makes it harder to hear or understand the original signal. So by understanding this type of causes of the noise, we as engineers, we can design better system to reduce the noise and make communication clearer. Okay, next. Now let's talk about loss. Loss is when signal gets weaker as it travels. And here is why that happens. First of attenuation. This is a gradual weakening of a signal as it travels through a medium, like a cable or in the air. The further the signal has to go, the weaker it gets. It's like shouting across a field. Your voice gets quieter the further away you are. So when you're in a football field, like you're here and your friend is in the at the end of the field, he can't hear you properly. This is one of the causes of loss. And second one is absorption. This happens because of the medium the signal is traveling through soaks up some of the signal's energy and turns it into heat. So, for example, in fiber optics, some of the light signals get absorbed by the glass, making the signal weaker. Then there is the reflection and refraction. When a signal hits a boundary between the materials like air and glasses, as shown in the picture here, some of the signal bounces back, and this is called the reflection, or bends, and this is called the refraction. This means some of the signal energy is lost. In wireless system, polarization mismatch can cause loss. This happens when the signal and the receiver antenna aren't aligned properly. It's like trying to catch a ball with your eyes closed. Like you can't even catch the ball. So you might even miss it. Okay, next. Another big problem, another big cause of loss is dispersion. This is when the signal spreads out over time because different parts of it travels in different speeds. It's like running in a race, spreading out because of some are faster than the others. This is a big problem in fiber optics and as well as wireless communication. And in wireless communication, we have something called free space path loss. It's when the signal gets weaker as it spreads out in open space. It's like how a flashlight's beam gets dimmer the farther it shines. And lastly, we have coupling loss. This happens because when the signal moves from one part of the system to another, like through connector or splices, if the connection isn't perfect, some of the signal's energy is lost. And here is some of the example of the cables, or we can say the connectors. So noise and loss are big challenges in communication system, but we can reduce their effect by using better materials, amplifiers, and error correction. Next, Mr. Jonathan will explain more on that.
Hey, thank you, Mr. Omar. So I'll be talking about reducing noises in communication system. So the first way we can reduce noise is by amplifying the signal. If you think about it, if you amplify a signal to a very big, very intense signal, the small noises in the signals become irrelevant. So by amplifying a signal, you are able to make the error lesser percentage. In a way, you are able to detect the error better and remove the error. So another way you can reduce noise is by using digital signal processing. So usually noises occurs, it's like more, the noises happens more on like analog signals, which is because it's like a range of values, like a wave like that. So by converting these waves of values into a digital signal, a digital signal operates based on discrete values, based on like zeros and one. So 0 for 0 volt, or like high voltage maybe 3.3 volt or 5 volt. So as you can see from this picture here, you can see that the noises affects the signal, but then you can still see clearly like which one is considered a high voltage and a low voltage. So in this method, you're able to identify clearly even though there is a lot of noise in the communication system. Next, you can also, one of the most common ways to reduce noise is actually by just shielding the cable itself. So with a braid and foil, you're able to isolate the conductors inside a wire from the external environment. So the external environment is very unpredictable. You can be next to like a machine, or maybe next to like a power cable, and that creates a lot of induced EMF in your conductors. So by having a braid and foil to protect all your cables, they're able to absorb the EMF, the induced EMF, so that it would not affect the signals within your conductors itself. Next, another common method is by filtering. So actually filtering happens in almost all devices that receive your signals, because especially for wireless communication, the signals get really messy. So by filtering, you're able to remove like the higher frequency noises and the lower frequency noises, and therefore you are able to get your original signal back. As you can see from this picture here, like the initial before the filtering is the noises is so much and it's like very hard to determine, but after the filtering, you're able to get back the original signal easily. Next, I would like to talk about ways that you can reduce losses. So actually losses is quite interesting ways to reduce it, because it's actually it's very hard to reduce losses, because it's something that happens. Like, it makes sense that after a while your signal is going to degrade over distances. So in a way, we can't really fully reduce losses, but we can try to reduce like the amount of losses we get per transmission. One way we can do it is by using higher quality materials. So by using higher quality materials like copper with less resistance, you're able to like transmit your signals with lesser losses in the conductors, because as mentioned just now, there is like attenuation and absorption losses. So by doing this, you are able to reduce these kind of losses. And then another way is by using fiber optic technology. So instead of using electrical signals that are electrical or radio signals that are commonly used in wireless and non-wireless communication system, fiber optic is one of the most popular ways for reducing losses nowadays, because most fiber optic technologies are used in like cross-continent transmission. Because the one good benefit about fiber optics is because they're using light as the communication medium, it's able to has lesser loss over time compared to electrical and radio waves. So by implementing fiber optic technology in communication mediums, you're able to reduce a lot of losses from that. Next, I would like to conclude on what we have mentioned and discussed just now. So noise and losses are inherent challenges in communication system that affect signal quality and reliability. Noise adds unwanted interference, leading to distortion of or errors in the transmitted message. While on the other hand, losses diminishes signal strength as it travels through the medium, making it difficult to receive it accurately. Therefore, we need effective strategies like amplification, filtering, and advanced signal processing, which are essential to minimize these issues. Addressing this noise and losses is fundamental to create an efficient and reliable communication system. That's all from us. Thank you. Now I would like to pass to Mr. Haziq to proceed with the next section.
Thank you, Mr. Jonathan, for concluding the lecture. Understanding the source and effect of noise and loss is essential for designing a system that can withstand environmental challenges, maintain signal integrity. By addressing these factors, modern communication technology can deliver high quality, reliable, and efficient performance across various applications. Next, we will have a quiz 2. So for this quiz too, it is to see that this service learning can actually help you guys to understand more on the topic of noise and loss in communication system. Alright, you guys can scan the QR code, or maybe you guys can just use the link before. So it's already 9:53. So those who are still answering the question, you guys can take your time. And next, I just want you guys to help us in answering this evaluation session. Just use the previous link too, and at the session type, just click on the evaluation, this evaluation survey. I think that's all for now. Before ending, maybe we can have a photography session as a proof for today's meeting.
So are you ready? 3, 2, 1. Okay, thank you everyone for joining us today. It was a pleasure having you all.
Alright. Thank you, Mr. Omar, for the photography session. So I would like to thank you all for participating in this service learning activity, as this activity help us in completing our subject tasks and also may help you guys to understand things that are happening around us. You guys have any question regarding this topic, you guys can contact any panels or may also ask in the WhatsApp group. Thank you all. Will be dismissed. All right. Thank you guys.